Hi everyone, welcome back to Lulumath. This video is on determining greatest common factors of polynomial expressions. This is an important skill that you're going to need to know because once we start factoring, you're going to need to know how to figure out what greatest common factors of expressions are going to be. So this video, we're going to talk about what you need to do in order to find greatest common factors. So in our first example, we're asked to use prime factors to determine the GCF of the following terms. So our first term is 24x squared y cubed. So I'm going to take my coefficient, and because we're going to use prime factors, I'm going to create a factor tree for 24. So some factors of 24, we can divide 24 by 2. That's a prime factor, so I'm going to stop there on my left branch. But 24 divided by 2 is 12. 2 times 12 is the 24 we're looking for. 12 is divisible by 2, another prime factor. We've got 6 left over, and then 6 is also divisible by 2, and then we have 3 left over, which is also a prime number, okay? So we can say that 24 x squared y to the power of 2 is essentially just 2 times 2 times 2, okay? Multiplied by this 3 right here times 3, okay? And then we also have an x squared here, and x squared means x times x, okay? And then we also have y cubed, and y cubed means y times y times y, okay? So this is what 24x to the power of 2, y to the power of 3 is, okay? Now, let's do the same thing for 18. So for 18 here, we can take 18 and divide 18 by 2. 18 divided by 2 is 9. And then 9 is divisible by 3. We've got 3 and 3 left over. So for 18xy to the power of 4, z or z, we're going to say that that's equal to, we know it's going to, we have a single 2 here, times, we've got 2 3's here, 3 times 3, okay? And then here we have an x, so we've just got one x, so we're going to write that out. And then we have y to the power of 4 right here, so we'll write times y times y times y times y, and then we're going to copy down this last value right here, our last part, which is z. Okay, so now greatest common factor, I need to find all the factors that are in common with all of my terms that I have here. Okay, so now I'm going to look and see what's in common. So remember, GCF means greatest common factor. So I'm going to look at all my factors and see what's in common. So for my 2's, I have 1, 2 in common right here. For my 3's, I have a 3 in common right here with this 3 right here. For x's, I have just a single x in common right here. And then for y's, I have 3 y's in common right here. And then for z or for z, I have nothing in common between both of my terms. So because it isn't in both terms, it's not part of my GCF. So therefore, I can say that my GCF is going to be equal to, now a lot of people will say 2 times 2, but there's only 1 2 in common with both of these. So it's just simply 2 times 3 times x times y times y times y, which we can shorten to y cubed. So therefore my GCF is 6xy cubed, or 6xy to the power of 3. Now, the thing is, you're not going to want to always write out each term that you have here, expand it out as follows to find your GCF, because this is something that you're going to want to be able to eventually, with some practice, be able to identify a little bit more easily and a little bit more quickly. So, how can we do this a little bit more easily? Well, first thing I want to do is I will look at my coefficients. So what's the greatest number I can divide 24 and 18 by? The 6 right here. Now, the next part that we want to look at, however, is our variables. So for our variables, we ended up looking at our x squared and our x. Now this x has an invisible exponent of 1, so it's x to the power of 1. So we want to find the largest factor that you can divide both of the terms by. So here, if we've got x to the power of 1 and we've got x to the power of 2, I can't divide x to the power of 1 by x to the power of 2 without having some type of a fraction. It's not possible. So the largest thing that I can divide x to the power of 2 and x to the power of 1 by is this x to the power of 1. Well, what does that mean that I should do? I should look at my exponents and choose the smaller of the options. So we're going to choose the smaller option, okay? So let's do the same thing with our y's right here. So we have y to the power of 3 and we've got y to the power of 4. So I want to be able to divide both terms by the largest possible factor, and I cannot take y to the power of 3 right here and divide it by y to the power of 4 because, again, I will get a fraction. So same thing right here, I want to choose the smaller option. So my two choices are either y to the power of 3 or y to the power of 4. This 3 is going to give me that smaller option, okay? Now let's talk about our z or our z that we have here. So we've got z to the power of 1 right here. And then we have no z's here at all. There is z to the power of 0. There's nothing there. So as if we had to choose, we would choose 0 because 0 is smaller than 1. And that's another reason why z is not part of our GCF, besides the fact that we're looking for a common factor. So in the next example, we want to find the GCF of the following terms. We've got 21a to the power of 3, b to the power of 2c, and we also have 14bc, okay? So the first thing I want to do is find, well, what's the GCF of my coefficients? What is the largest number that I can divide 21 and 14 both by? So I'm going to look at this a little bit differently just because I want to give you some other options in case you don't like the factor tree. So I'm going to look at 21 and I'm going to see what are some numbers I can divide 21 by. Well, I can divide 21 by 1 and I get 21, and I can divide 21 by 3 and I will get 7. Now for 14, I can divide 14 by 1 and get 14, or I can divide it by 2 and get 7. What's in common with these two sets of factors is the 7. It's the largest number that's in common. So that means that my GCF is going to have a coefficient of 7. Now looking at the a's that we have here, we have a to the power of 3, but there is no a in this expression right here. So because there's no a and it's not in common, we don't include a in our GCF because remember the C in GCF means common. Okay, now let's go ahead and look at our b's. So we've got b to the power of 2 and we've got b to the power of, this is an invisible 1 right here. So if we've got to choose between a 2 and a 1, we are going to have b to the power of 1 as our GCF right here. Again, because the smaller number between 2 and 1 is 1, and also because we can't, that's the largest term that we can divide both of these by, okay? And then lastly, for our c's, we've got c to the power of 1 and c to the power of 1. Well, it's the same exact thing, so we can say c is part of our GCF. Also, if our two choices are to the power of 1 and to the power of 1, they're both the quote-unquote smallest one. So therefore, my final answer for my GCF is going to be 7BC. Okay. Okay, our last example asks us to find the GCF of 16UVW, 6W, and 9VW squared. Okay, so the first thing we're going to look at here are our coefficients. So I want to find the greatest common factor of my coefficients. So I've got 16, 6, and 9. So I'm going to go ahead and make my my chart with my list of factors for each one of these coefficients, okay? So 16 is divisible by 1, It's divisible by 2 and I get 8. It's not divisible by 3 and it's divisible by 4, 4 times 4. So I've gotten to a point where I've started to repeat, so I've listed all of my factors. 6 is divisible by 1, so 1 times 6 is 6. I can divide 6 by 2. 2 times 3 is 6. The next number is 3, but it's already in my chart, so I'm all set with 6. And then for 9, 9 is divisible by 1. 1 times 9 is 9. 9 is also divisible by 3. 3 times 3 is 9, and then I've listed all of my options here. Now, if you notice, there's a 2 in common with the 16 and the 6, but there is no 2 in common here, so that means that I can't use 2 as my GCF, okay? If you also notice, there's a 3 in common with the 6 and the 9, but there is not a 3 in common with the 16, so same thing, I cannot use that as part of my GCF. So my GCF has an invisible coefficient of 1. So when I write this out right here, I'm just going to say that it has a 1 right here. Okay, this is not my final answer yet, though. I want to have it as simplified as possible. So now let's look at our next term that we have here, or our next part of our first term. So we've got u right here, but there is no u in common with this term or this term, so u is not part of my GCF. It's not in common here, okay? So now let's go ahead and look at our v. So there's a v in common with the first term and this third term, but it's not in common with the second term, so therefore v is not part of my GCF either, okay? So let's look at w. We've got w to the power of 1, w, and w to the power of 2. Sorry, this up here is also w to the power of 1. So my choices are either 1, 1, or 2. The smallest exponent is 1, so it's 1w. Again, you need to be able to divide everything through by this w right here. So our greatest common factor is simply just w. Okay, that's it for this topic. Thank you for watching this video. If you have any questions, please let me know in the comments or at lulumath.com. Also visit lulumath.com for notes, filled in or blank versions of the notes. Stay tuned for the next video because we will take it a step further and show you how to use the GCFs that we found to factor by GCF. Please subscribe and share with anybody that you might think will find this video helpful. Have a great day and we'll see you next time. Bye.